Hi everyone. So in this video, we're going to look at the two balancer strategy vaults that we've built. One is the meta stable 2-token Aura vault, and the other is the boosted 3-token Aura vault. So the structure of both these strategies is very similar. Mainly the main differences are some of the math components due to differences in how the balancer pools themselves work. So the metastable 2-token vault is intended to be used for the wrap staked ETH pool, and the boosted 3-token vault is intended to be used for the boosted 3-token vault, which is a USDT, USDC, and DAI vault. So we'll go through this, just assuming that you have an understanding of how the iStrategy Vault interface works and the base strategy vault itself. So the 2-token Aura vault initializes itself. It approves tokens and things of that nature. So we'll take a look at deposit and redeem first. So on deposit, what we'll do is we'll decode the parameters. We will go grab the strategy context. So in order to maximize the amount of code reuse we can have, we have these different structs that return different contexts, which are essentially different batches of variables for different parts of the vault. So we're going to go get this context here, and then we're going to deposit. So to deposit, we'll go to our pool context, which is the 2-token pool context. So we'll get 2-token pool utils. So so we've called deposit here. So we in a 2-token pool context, what's going to happen here is that the user is going to borrow 1 token of the pool, and then join that pool either single-sided or optionally, if they want, they can trade on a different DEX. They can trade some of the token they borrowed. In this case, maybe it's ETH. So they're borrowing ETH to go into the ETH wrap staked ETH pool. They can either go in ETH single-sided, because this is a stable, like a metastable pool. The IL is limited, the permanent loss is limited. But if they wanted to trade on a different DEX like Curve or UniV3, they could specify that in the params, and we would execute that trade for them. If we did, then they would have both ETH and wrap staked ETH at this point, and then we would then join the pool with both of those amounts. But in general, most users are going to just come in with the ETH and join single-sided into this pool. So when we join pool and stake, we'll take a look at that. This is pretty simple. It's going to call the balancer pool. You can look at balancer utils, but there's not too much to see here. We're just calling balancer vault with join pool with an exact tokens in request here, and we'll return some amount of BPT. So the user has received this amount of BPT. One thing we'll do here is we'll check what's called the Bpd Threshold. So for both of these vaults, there's an emergency condition. If for whatever reason the strategy holds too large of a position within the pool, too large of a share of the liquidity, it will have problems exiting its position. So if we go above a certain threshold that's defined by our risk parameters, we will revert, and users can no longer join the pool through the vault. We'll take a look at emergency settlement, which allows us to reduce the share like reduce the BPT in the case that we do go over the threshold as well. And the last thing here is we're gonna transfer these BPTs to Aura for staking. This is how we'll maximize the yield boost for the BPTs. So that is that's basically entering the vaults. Redemption works similarly, so we're gonna also come into redeem here and take a look at this code. So one thing I forgot to mention when we're depositing is that although we get some amount of BPT, we do have to convert this to strategy token denomination, which is 8 decimal places. So BPTs are 18 decimal places, so we truncate off the last 10 decimal places and return the 8 decimals precision back to notional. For these balancer strategies as well, we maintain a global strategy token count. This is the one piece of state that is maintained on the balancer vault, on the vault itself. This is used in a number of places, like settlement, to ensure that we don't overstep our bounds in a single maturity. To make that a little bit more clear, so because the borrowers that are using the vault are borrowing different maturities, there's, this vault might support both a 3-month and a 6-month maturity. It's holding a total number of BPTs, which is not split up into those 2 buckets. So we maintain separate balance accounting for each maturity. So we'll need to do a little bit of checking for that. So when we come into redemption, we'll receive a strategy token amount. So we'll change that into a BPT claim. This is a BPT claim on the vault itself. Now, it's important to note here that as we boost the vault, we'll be receiving various incentive tokens. Those incentive tokens will be sold and sold for ETH and essentially deposited back in the strategy to increase the overall BPT claims. So if a user came in with 1,000 strategy tokens equaling 1,000 BPTs, balancer pool tokens, maybe when they come back a couple months later, they may have 1,200 BPTs, a claim on 1,200 BPTs, but they'll still have 1,000 strategy tokens. The extra 200 BPTs came from selling reward tokens and compounding that yield. So the user is going to receive their BPT claim here. What we'll do is exactly the opposite of what we did before, is we'll unstake and exit the pool. So that's just pulling our BPTs out. We'll get balances. We'll get balances in both ETH and wrap staked ETH. If we want, ETH and wrap staked ETH, that's right. And then we will sell the secondary balance. So the user can define how they want that balance to be sold through their redemption parameters, and we will execute a trade. Here we execute what's called a dynamic trade. So we'll go look at the oracle, and we will prevent the user from selling at a larger slippage than the oracle, for like a larger slippage than allowed from the oracle price. So here we'll go ahead and update that counter that we had before, and that will sort of be the redemption. So when we're done redeeming, all of the balance will be denominated in ETH. So all the wrap staked ETH will have been sold for ETH, and that's the balance that will be returning to notional, which is what they've borrowed. Now we'll look at convert strategy to underlay. So in order to value a strategy token balance, we'll first convert it to a Bpd claim, and then we will get the time-weighted primary balance. So what that is up here. So what we'll be doing is actually querying the balancer pool itself and getting its oracle prices. So this Bpt price is the value of 1 Bpt oracleized in the 0 token index. What we'll do is we will convert that to the primary amount. So so we'll scale it up given how many Bpt claims we have and return the amount in ETH in our case here. So that that covers deposit and redeeming and valuation. So the last two things we'll look at are settlement. So we have settling the vaults pre-maturity and post-maturity. So these generally work the same. The main difference is that post-maturity, if for whatever reason the vault has not been settled post-maturity, which it really should have, we sort of take over and sell it down like with a little bit faster. This generally should not be the case. Most of settlement should happen prior to maturity and with a more restrictive slippage limit. And the third thing that we talked about was settling the vault in the emergency condition. So the emergency condition will exist prior to the settlement window. So the settlement window will be 3 days prior to maturity. At that point, we're going to settle the vault under normal conditions. Prior to that, if we see that the vault is above its Bpd threshold, we can call settle vault emergency, and what that will do is reduce its Bpt holdings in a specified maturity. So let's take a look at token vault helper. So let's take a look at the settlement code. So these all sort of do a bit of authentication and checking, and then they all go into this execute settlement. So so what we'll do here is we will get the expected amount of underlying that that should be redeemed, and this is based on the oracle price. And then what we'll do is execute the settlement on these using settlement retest, right? So we'll get how much cash is required to settle. It's generally going to be the case that we will have a surplus here. Now, we don't want to have a so what's going to happen in this method is that we're going to be redeeming strategy tokens to cash. So we're going to be selling some amount of strategy tokens, going through the redemption, and selling wrap staked ETH and ETH back to ETH. So if we don't need to sell all of the strategy tokens, that is preferable to accounts, because any strategy tokens remaining after the debts are repaid will continue to earn yield. They won't earn leverage yield, but they will continue to earn yield just like the rest of the BPTs on this contract. So we have a check here to ensure that we don't sell too many strategy tokens. You know, we may need to sell a little bit in excess, but we don't want to sell massively oversell in excess. So we'll do that check here, which is a setting set by governance, and then if we have a negative surplus here, meaning that we've raised sufficient cash to repay all the debt, we can go ahead and call settle vault on notional. That will sort of snapshot the valuation post maturity. So that is settle vault. In settle vault emergency, we'll see that, you know, there are some emergency settlement parameters which essentially authenticate the withdraw thresholds, and then calculate what share of the balancer pool tokens we would need to settle to get under that threshold. Now, the last thing we'll take a look at here is reward reinvestments. So, as I mentioned before, when an account enters this vault, they'll have some amount of BPTs equal to their amount of strategy tokens, but over time, their claim on BPTs will increase as we reinvest the rewards into more BPTs. So, so this is going to be called by a bot. It's going to come into this method with some trading parameters that it has, and we're going to go ahead and claim the reward tokens and execute a number of trades. Apologies. At this point, I believe that the rewards will already have been claimed through a separate method, and then we're going to execute these reward trades. So each one of these reward trades when we execute the reward trades, there will be a max reward slippage limit applied to the tokens that we're selling. So, so that'll be set by governance. So, and that'll limit the slippage that we can sell these tokens for. Then we go ahead and validate that the spot price, the current spot price in the pool, and its oracle price are within some bounds, so that we know we aren't, there's no sort of flash loan manipulation or MEV occurring on the pool before we join. And then at that point, we're just going to join and increase the BPT amounts on the vault itself. So I won't go into the boosted 3 token vaults in the same detail. Its structure is very similar. The main difference is going to be sort of some of the internal logic that we use when we enter and exit the vault. So with that, that kind of concludes like a review of the balancer strategies.